अस्सलाम वालेकुम डियर स्टूडेंट्स, वेलकम टू द लेक्चर ऑफ द क्वांटम मैकेनिक्स। आज के लेक्चर में हम प्रॉब्लम नंबर 2.25 की सोल्यूशन की बात करेंगे। कंसिडर एन ऑपरेटर ए सो दैट ए एंड ए टाइगर कम्यूटेटर इज इक्वल टू 1। जी एवेलुएट द कम्यूटेटर। हमने इस कम्यूटेटर को एक्सपेंड करना है यूजिंग दिस वन, एंड इस कम्यूटेटर को एक्सपेंड करना है यूजिंग दिस प्रॉपर्टीज। कहते हैं कि use the definition that the operator commute to 1 and use the fact that an operator commuting with itself is 0 to solve the identities। कि अगर हमारे पास एक ऑपरेटर खुद के साथ कम्यूटेशन कर रहे हैं तो वो क्या होगा, 0 की इक्वल। कंसिडर द कम्यूटेटिंग ऑपरेटर, जो हमारे पास गिवन ऑपरेटर है ए टाइगर ए एंड ए, जो हमारे पास गिवन है। तो हम इस पे प्रॉपर्टी अप्लाई करेंगे ए टाइगर ए, जो कि हमारे पास ए बी इंटू सी वाली प्रॉपर्टी है। तो वो हमारे पास ए टाइगर ए एंड ए प्लस ए टाइगर ए इंटू ए, एंड यू नो दैट ए इफ ए टाइगर इज इक्वल टू 1 देन ए टाइगर एंड ए विल बी, अगर इन दो को ऑर्डर आप तब्दील करेंगे तो दैट विल बी इक्वल टू -1। तो हमारे पास ये होगा ए टाइगर एंड ए, इसका हमारे पास कम्यूटेटर क्या होगा -1 एंड ए, और ये जो सेल्फ कम्यूटेशन है दिट विल गो टू 0, तो दिस विल माइनस ए आ जाएगा। एंड सिमिलरली अगर हम इस कम्यूटेटर को देख रहे हैं, ये ए टाइगर ए एंड ए टाइगर, इसको हम एवेल्यूएट करना चाहें तो आप देख सकते हैं कि इसको अगर हम ए मान लें, इसको हम बी मान लें, इसको सी मान लें, तो हमारे पास ये फार्मूला है जैसे हमारे पास एसोसिएटिव वाला है ए टाइगर ए टाइगर, इसको हम लिख सकते हैं ए टाइगर इंटू ए प्लस ए टाइगर इंटू ए टाइगर, यानी आप इसको ए बी एंड इसको सी कह सकते हैं। तो आप इसको लिख सकते हैं सी इंटू ए कम्यूटेटर बी एंड बी इंटू ए कम्यूटेटर सी, एंड सब्स्टिट्यूट यू नो दैट ए टाइगर विल बी इक्वल टू 0 and a into a dagger which is given a and a dagger is equal to 1, so just substitute a dagger is equal to 1 and this will a dagger and this goes to 0, so we have left with an a dagger a and a dagger commutator is equal to a dagger. Again, if we go to the part 2 of this question, if the action of a and a daggers, if the action of a and a dagger on the state a are given by a operator which is lowering operator apply on state a is equal to give this eigenvalues under root a and reduce the state by 1, and similarly if a dagger apply on this it gives this eigenvalue a plus 1 plus increase this state, and if this is the, if these two states are equal it means it will give the canonical delta, and then we have to calculate this number this and this. So first we will evaluate this one. So if we look back to solutions, this one, use the operation on the state vector. If we apply a on state a, this will give this eigenvalues, and with this reduced state a will be lower by one number a minus 1, and a daggers apply on a, this will give this under root a plus 1 and a plus 1. This is the by definition, because we know from the basics of cats and bra algebra. Using the normal properties, this is also given. You know that if these states are equal, so definitely their inner product will be equal to 1. If this is not equal, it means this will give to 0. So this we have to evaluate this expression a and a plus. First this a will apply on this state. You know that when this a apply on this a plus 1, a apply on a state, that gives under root of that number with the eigenvalues and reduce that state by no number. So when this a apply on this a plus 1, so what you expect that this is the lowering operator, so that will reduce. So this a will, when this a apply on this number, so it will give us a plus 2 and it's increased by state a plus 1. So a plus 2 again will come out, and a plus 2, so these two number, this number and this number is not equal, so this will be equal to 0. Similarly this is a plus 1, a dagger and a. So when you know that a dagger apply on this state, this will increase the state by 1. A dagger apply on this state will increase a plus 1, and this with eigenvalue and a plus under root a plus 1. This will come out, then a plus 1 and a plus 1 will be equal to 1. This is the eigenvalues. Similarly, you can evaluate this expression a dagger by first applying a on this. This will give some eigenvalues and reduce the state, and then a dagger with some eigenvalues, and eigenvalues is the constant number which will come out, and you will left with some state. If these state are equals, this will be equal to 1, otherwise it will be equal to, because this a and a are equal, this will be equal to 1 and gives this eigenvalue. Similarly, if I maximize it, we can find out a operator, a dagger and a. This first a dagger will apply on this. This will give some eigenvalues with some state, increase some state, and then we will apply a on this remaining state. It will give again some eigenvalues and reduce state. Similarly, for the part C, use the definition, we can evaluate this a plus a dagger whole square. First we will evaluate this whole square, a dagger square plus a dagger, and this. Now this a square will apply separately, a dagger square will apply separately, and this will apply separately. You can use this the previous property and evaluate this whole term. I am not. This will be equal to 2a plus 1. Similarly, we can apply a into a minus a dagger whole square on this. So first we will evaluate this square, a square plus a dagger square minus a dagger a minus a dagger a into a, and we will evaluate this, and this a square will apply separately on this. This a dagger will be applied separately, this will apply separately, and similarly this bra from the left side will apply on this, and we will left with this number. You know that this bra from the left side and this cat from the right side will apply on every operator within the brackets. Okay, now we can use the property as we have previously used. This will give us minus 2a plus 1. This is the solution for the C parts. So I will stop at this lecture, and we will continue this part, and we will continue from the next question, next recording.